Hi, this is Hilal. In this video on mathematical economics series, we will try to solve a numerical that was asked by a sister about the input-output economic model. The question is something like this. We are given an input-output table, and from there we have to determine the output when the final demand changes to 100, 200 and 300 for agricultural, manufacturing and service sectors respectively. That is, when this outside demand, this final demand changes from 35 to 100, this changes to the manufacturing outside demand changes from 115 to 200, and this service sector demand changes from 70 to 300. Okay, so we will try to see how to solve this. First of all, we will try to comprehend what does this input output table tells us. Okay, so this input output table will tell us. First of all, let us take this very number. This 20 here tells us that manufacturing sector is consuming 20 units of worth of output produced by the agriculture sector. Similarly, this 60 tells us that manufacturing sector is consuming 60 units of the output produced by service sector. Okay, similarly here this 45 will tell us that service sector is consuming 45 units of worth of output that is produced by the manufacturing sector. And we can see here across the row, this shows us that agriculture sector is producing 15 units, 20 units, 30 units, okay, which is internally consumed by the industries or sectors, plus the outside demand that is 35 units. Okay, across the row we can add them, and gross output is 100. Similarly, across any column we can see that it is the consumption by each industry. That is, we can see here agriculture sector is consuming 50 units of the output produced by itself. That is, agriculture sector is consuming 50 units of output produced, okay, for its internal consumption. Similarly, here we can see that agricultural sector is also consuming 30 units of output produced by the manufacturing sector, and it is true for all the things here. Okay, so this is how we comprehend this input output model. Okay, so we will try to solve this question now. First of all, what will we have to do? We will name them here. Okay, so let us say this is A11, so I will use another another color. Let us say this is A11, this is A12, this is A13, this is A21, A22 and A23. Similarly, this is A31, A32 and A33. Now what does these numbers tell us? So first I will try to uh, show you this this very, what does this A11 tells us? A12, it simply tells us that dollars value of output of agriculture sector, okay, consumed by manufacturing sector. Okay, manufacturing sector. Okay, this A12 tells us dollars value of output of agriculture sector consumed by the manufacturing sector. Okay, so first of all, we will try to form a matrix. Similarly, we have A12, A13, and you can get easily what does these numbers tell. Let us say this, we have this A23. This A23 tells us, this very number tells us that dollars value of output of manufacturing sector consumed by service sector. Okay, so first of all, what will we try to do? We will try to see the per unit output produced by each industry. Now we have to form the input output coefficient matrix. That is formed by, first we find this B11 is equal to A11 divided by x1. Our x1 would be this 100. Okay, so we will get here 15 divided by 100. Okay, what does this number tell us? This simply tells us in the output of 100, in the output of 100, 15 units are being used from the agricultural sector. Okay, so I will show you here. B21 is equal to A12, sorry, A21 divided by X1, which would be equal to 30 divided by 100. Okay, so I will try to show you what does this mean. This simply tells us that in producing 100 units of output of agriculture sector, 30 units are being used from the manufacturing sector. That is, it simply tells us dollars value of input. So I will write here, it shows us dollars value of input from manufacturing sector required to produce $1 worth of output of agriculture sector. Okay, so what does this tell us? It simply tells us this this B21 tells us dollars value of input from the manufacturing sector. Okay, from the manufacturing sector required to produce $1 worth of output of agriculture sector. Okay, it simply tells how much amount of output from the manufacturing sector is used in 1 unit of agriculture sector. That is, we can see here 30 units of manufacturing sector are used to produce 100 units of agriculture. Okay, agriculture sector. Okay, so in 100 units of output produced by the agriculture sector, 30 units are being used from the manufacturing sector. So by unitary method we can see that for in $1 worth of output, that is 1 unit, to produce 1 unit of agriculture sector, we need 30 divided by 100, that is 0.3. Okay, we need 0.3 units from the manufacturing sector to produce $1 worth of output of agriculture sector, and same is true for all these numbers. Okay, I hope I am making myself clear. It is getting lengthy, I know that very well, so I will just rub this. Similarly, we have B31 is simply A31 divided by X1, which would be equal to 20 divided by 100. Okay, as simple, you can understand that 20 units are used in producing 100 units of output of agriculture sector. Okay, so we are actually trying to figure out the how much contribution is made by the service sector, in this case in 1 unit of output of agricultural sector. Okay, so we will write here, this is 0.15, this is 0.30, and this is 0.20. Similarly, we can calculate for the other numbers, that is B12 would be equal to A12 divided by X2. We have B22 would be equal to A22 divided by X2, and B32 would be equal to A32 divided by x2. Okay, so here we have the numbers. A12 is our 20, so this is 20 divided by our x2 is 200. Okay, what does this number tell us? Simply it tells us that in producing the 200 units of manufacturing sector, in producing 200 units by the manufacturing sector, 20 units are used by 20 units are being taken from uh, 20 we have from the agriculture sector. Okay, so in 20 units of output of manufacturing sector, 20 units are being used from the agricultural sector. Okay, similarly we have A22. Our A22 is 10 divided by 200, and we have 60 divided by 200. Okay, when solving these very fractions, we will get the numbers like we have 0.10. I have calculated them 0.05 and 0.30, and similarly we can calculate uh, B13 is equal to A13 divided by x3, and B23 is equal to A23 divided by x3, and we have B33 is equal to A33 divided by x3, which would be equal to, so I will just try to write here, which is equal to A13. A13 is 30 divided by 150. We have 45 divided by 150, and A33 is nothing here, so this will be 0 here. Okay, because this is 0 divided by 150, so I will write here 0 divided by 150, which comes out to be, so I will write here, this is 0.0.20, this is 0.30, and this is 0.00. Okay, so these are the technological coefficient matrices, so we will write them in matrix form. For that I need to rub this out. Okay, so let me rub this. So our B, which is a technology matrix, would look like this. We have calculated B11, B12, B13, B21, B22, B23, B31, B32, and B33, and we have calculated these values earlier. These are equal to, we have 0 0.15, 0 0.30, 0 0.20, we have 0 0.10, 0 0.05, 0 0.30, we have 0 0.20, similarly 0 0.30 and 0. Okay, this is our technological matrix, or we call it input output coefficient matrix. It simply tells us to produce 1 unit of output, how much units of other industries are used. Okay, so this is our input output matrix. Okay, now to give you an idea how does this look, let us say we have an economy. We can see here, in an economy we have these sectors. That is, in an economy we know that some output would be consumed by the industries, that is for self consumption by industry. Here we can see this is all the self consumption by the industries, that is one industry is consuming the output of the other industry. Okay, from the consumption, and some part would be demanded by the government sector, by government or household. Okay, household. Okay, which would be equal to our total output. That is, our total output would become composed of the internal demand plus the final demand. Internal consumption is the consumption by the industries itself, and some consumption which is demanded by the outside. Okay, so these two will give us the total amount produced. Let us say this is equal to x. Okay, now we have this b. Okay, then our total consumption would be look like this, that is b times x plus the government spending. Let us say this is d, or government plus household demand should be equal to x, that is total amount produced would be equal to bx plus d is equal to x. Okay, now what does this b is? B is the input output coefficient matrix, that is to produce 1 unit of output. Since we have to produce x units of output, so this is b into x plus the demand which comes from the outside should be equal to the total total output produced. Okay, so if we can see here, we can write this like this. We can write x minus bx is equal to d, or if we take x common, we will get 1, or I minus b is equal to d. Okay, or x is equal to I minus b inverse d. Okay, so this very equation will give us the output level to be produced when the final demand changes from 100 to 100 and 300. Okay, basically I have made the video on the input output model earlier, and there I have shown you in detail how do we interpret these very numbers. Here I am just giving you some basic recapitulation about that. Okay, so that means we have to form this very equation, that is uh, x should be equal to I minus b inverse d. So we have to form this very thing. For that we have got this b. Okay, now I minus b would be equal to, simply I is our singular matrix, that is 1 0 0 0 1 0 0 0 1, and from that we subtract this b. Our b is 0 0.15, 0 0.30, 0 0.10. Here we have 0 0.20 also, so 0 0.05, 0 0.30. Similarly we have this. Okay, so here we can get, when subtracting 1 minus 0 0.15, so we will get here 0 0.85. Here we get minus 0 0.30. Here we get minus 0 0.20. Similarly we have minus 0 0.10, 0 0.95, minus 0 0.30. Okay, and similarly we have minus 0 0.20, minus 0 0.30, and here we have 1. Okay, so this is our Leontief input output matrix also. Okay, so I will rub this out. Now to get the feasible solution, we have to satisfy some conditions. These conditions are something like that. We should get the numbers on the principal diagonal as positive, that is these numbers should be positive. Okay, this is the first condition, that is the elements in the principal diagonal should be positive. Here we can see 0 0.85, 0 0.951, these are all positive, that is elements conditions to be satisfied, so that we get a feasible solution is that diagonal elements rather we say this very diagonal is principal diagonal elements should be positive. Okay, this is the first condition for a feasible solution. Second condition is that since this is our I minus b, so I will write here I minus b. Okay, this is our Now second condition is that the uh, determinant of this very matrix, that is I minus b, it should be greater than 0 or it should be positive. So we have to find the determinant of this very matrix. Okay, how do we find the determinant? We take first number, that is 0.85, and mentally delete the row and the column in which it appears and multiply it by the this very subdeterminant, that is, so I will write here, we multiply it by these very numbers, that is 0.95 minus 0.30, we have minus 0.30 and 1. Okay, then we write first number is positive, second is negative. Okay, and this is from the determinant rule. Then we have negative, but since we have here also minus 10, sorry, 0. Uh, I will write here, this is minus 0.10. Okay, now we mentally delete this row and this column and take determinant of remaining elements, that is minus 0.30 minus 0.20, we have minus 0.30 and 1. Okay, similarly first is plus minus, then we have plus, uh, I will write here plus this very number, we have minus 0.20. Okay, and take the determinant of, we mentally delete this row and this column and take determinant of the remaining elements, which is minus 0.30 minus 0.20, and we have 0.95 and minus 0.30. Okay, and then we solve this whole stuff. When we solve this, we will get, because of the lack of the space, I will not be able to show you, you can easily comprehend this. So first I will show at least this very thing. Okay, what we write here, 0.85. Okay, and then what will we do, we multiply it by, we multiply these very numbers, we first multiply these very two elements on the principal diagonal, that is 0.95 into 1, that is 0.95, and then we have minus from the formula, also we have, then we multiply these very two numbers, we have minus 0.30 minus 0.30, minus minus is plus, so we will get 0.3 into 0.3 is 0.09. Okay, similarly here minus minus is plus, we will get 0.10, and similarly we can solve this very subdeterminant. And at last what I have calculated by the calculation, so I will write here, I have got 0.73 minus 0.04 minus 0.06, and which comes out to be 0.63, which is positive, which is greater than 0. So our second condition is also satisfied, that is, second condition was that the determinant of this very matrix should be positive, which we got here. Okay, so you can do this calculation by yourself. So these two conditions are satisfied. Now we can find the solution of the given problem. Okay, how do we find the solution? Now we have to find this very equation. For this we need to find the inverse. Okay, before we find the inverse, we have to find, so I will just try to recapitulate here the two conditions that we proved here, or try to visualize here. First one was that the principal diagonals should be positive, that is, principal diagonals elements should be positive, and second one was the determinant of this very Leontief input output coefficient matrix should be greater than 0, or it should be also positive. These are called the Hawking-Simon conditions. Okay, these are the two conditions which must be satisfied so that we get a feasible solution. Now since these two conditions are satisfied, what we have to do, so I will rub this. Then we have to find the inverse. We have to find I minus b. I minus b we have calculated here, but we have to find I minus b inverse. How do we find the I minus b inverse? First we have to find the adjoint. Okay, adjoint of I minus b is equal to, how do we find the adjoint? So I will write, let us say this is a11, a21, a31. So I will write here a12, a13, a22, a23, a32, and a33. Okay, uh, we have to find these very numbers. How do we find these numbers? For that we have to find the uh, minors first. We have to find the minors of this very matrix. Okay, so we will calculate the minors. So minors is, first we have to find m11. First minor is simply the minor at m11 would be, we mentally delete this row and this column and take the determinant of remaining elements. That is, first minor is 0.95 minus 0.30 minus 0.30 and 1. This is our m11. Okay, similarly we find m, so I will write here m12. M12 is this is m12. M12 is, we delete, to find the m12 we delete this row and this column in which this number appears and take determinant of the remaining elements. So remaining elements are here 0.30 minus 0.30. So I will write minus 0.30, we have minus 0.20, then we have minus 0.30, and we have 1. Okay, this is our m12. Similarly we find m13. M13 is simply, we mentally delete this row and this column and take the determinant of the remaining elements. So remaining elements are here these very numbers, that is minus 0.30, minus 0.20, 0.95, and minus 0.30. Okay, similarly we find m, so we have to find then m21, m22, m23. So first we will see what is the number here. M11 would be, we multiply these very numbers, 0.95 into 1 is 0.95. Okay, minus, now minus into minus is plus, this minus is from the formula. 0.3 into 0.3 is 0.09, which comes out to be 0.86. This is our M11. Similarly, our M12 would be multiplying these numbers. Minus 0.30 into 1 is 0.30. Okay, and formula, the minus is by formula. Now minus into minus is here plus, so we got 2 into 3, 0.2 into 0.3 is 0.06. So we will get here minus 0.36. Okay, similarly we can find M13 multiplying these numbers, minus into minus is plus, so 0.3 into 0.3 is 0.09, minus is by formula. Now minus 0.2 into 0.95 which would be equal to, we have minus 0.19, which comes out to be 0.09. 0.09 minus minus is plus, so we get 0.19, which comes out to be 0.28. Okay, so we got M11, M12, and M13. Similarly we have to find M21, M22, okay, M23, and M31, M32, and M33. I will not be able to show all these. You can easily understand how do we find. Let us say we have to find M23. M23 would be, this is M11, M12, M13, M21, M22, M23 would be this very element. Okay, so here we mentally delete this row and this column and take the determinant of the remaining elements. So okay, if we delete this row and this column, so we will get this 0.85 and minus 0.20. We are deleting this row and this column. Okay, so we have 0.95 and minus 0.30. This is our M23. Similarly, you can calculate this M32, M33 and other stuff. Okay, now actually we have to find A11, A12 and A13, these very numbers. For that we first find the minors. Okay, so I will write here all the minors again which I have calculated. So first was M11, M11 we got, so that was 0.86, M12 that was minus 0.36, M13 was 0.28. Similarly we have M21, M21 is equal to minus 0.16, M22, M22 was equal to 0.81, M23 which we got minus 0.28. Okay, similarly we have M31, M31 was minus 0.32. Okay, we have then, I will write here, we have M32 because of the lack of the space. M32 was, sorry, our M31 was, I will write here, M31 was 0.22. This was minus 0.32 and M33 was 0.78. Okay, now to find A11. Okay, A11 is simply equal to minus 1. Okay, and adding these two numbers that are on the subscript and forming them as the exponent, that is 1 plus 1. Okay, and multiplying it with M11, it simply tells us that to find this A11 we take this minor and multiply it with minus 1 raised to the power of the addition of the subscripts. Okay, so this is minus 1. Now 1 plus 1 is 2. M11 which we got, which is equal to 0.86. Okay, we see here the power is positive, so we will get minus 1 square is positive, so we will get 0.86 again. Okay, similarly our M12, A12 would be simply equal to minus 1 raised to the power of the addition of the subscripts, that is 1 plus 2 times M12. Okay, so minus 1 minus 1, now 2 plus 1 is 3. I will write here 3. M12 is this minus 0.36. Here we can see any number minus 1 raised to an odd power would be minus 1. Now minus into minus would be plus, so we will get this number as positive, so this will get 0.36. Minus into minus is plus. Similarly you can use these numbers. So first was minus, second, first was positive, second was negative, third would be positive. Okay, number is 0.28. Positive into 0.28, so we will get here 0.28. Similarly this will come out to be negative, that is A13. A13 got, we got the value of A13 is 28. Similarly A21 is simply equal to, since this is positive, negative, this is positive, this would be negative, minus from the addition rule of the exponents, and minus 0.1 0.16. So we will get this minus into minus is plus 0.16. Similarly, we have this positive number. Okay, so A32, using the same method, A32 would be positive then. So this is equal to 0.81. You can use this very formula here. And we have A3, A11, A12, A13. So actually it is here A13. Now we have A21, A22. Sorry, it is A22, and we have A23. Similarly, this will get positive 0.28. Similarly, we will get all the numbers positive. Okay, because this would be plus. If I can say this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus. Okay, this would be plus. So all numbers get positive. So our A11, I will rub this out. For that I have made another video, rather a complete series on the matrix algebra. You can see how do we get these numbers. So, okay, so we got these very numbers here. The numbers are then, we got the adjoint is equal to, we have this 0.86, then we have 0.16, 0.22, 0.36, 0.81, 0.32, 0.28, 0.28 and 0.78. Okay, adjoint is simply equal to the transpose of this very matrix. Okay, this very matrix. So I will write here adjoint of I minus B is equal to the transpose of this very matrix. Okay, transpose. So I have transposed these numbers which I have calculated earlier. Now I minus B inverse is simply equal to 1 divided by the determinant I minus B times adjoint of I minus B. Okay, our determinant which we calculated, that was 0.63, and we multiply these numbers, that is 0.86, 0.16, 0.22, 0.36, 0.81, 0.32. Similarly, we have this number. Okay, when we multiply it, we get a number which is equal to, I will write here. So first I will rub this out. So I got the number, I got a matrix that is 1.37, 0.25, 0.35. Okay, we have 1.29, 0.50, 0.44, 0.44 and 1.24. Okay, when I solved this very thing, so our I minus B is this very matrix. I minus B inverse is equal to this. As I have shown you, actually we have to find x is equal to I minus B inverse times the D. Okay, then our x would be equal to I minus B inverse times D. Our I minus B is this very matrix 1.37, 0.25, 35, 0.57, 1.29, 0.50. We have 0.44, 0.44 and 1.24. Okay, and to this we multiply the demand, new demand which has changed, that is 100, 200 and 300. 100, 200 and 300. Okay, that means our x would be equal to, now we have to multiply these two matrices. Okay, and you know this is our row, this is our column. We multiply by row with column. Okay, we have 3 by 3 matrix, 3 by 3 matrix, and we have 1 by 3 matrix. Sorry, 3 by 1 matrix, 3 by 1 matrix. Okay, what would be the order of the new matrix? The order would be 3 by 1. We just delete these two numbers, and we take last two numbers, that is first and last, 3 is to 1, so we will get a column vector here. So we multiply this row by this column, that is it is done by 1.37 multiplying it by 100, plus 0.25 multiplying it by 200, similarly plus 0.35 and multiplying it by 300. Similarly we have 0.57 multiplying it by 100, 1.29 multiplying it by 200, plus 0.50 multiplying it by 300. Okay, similarly 0.44 multiplying it by 100 plus 0.44 200, plus 1.24 into 300. Okay, when solving this we get the numbers that are equal to 2 9 2 465 and 504. Okay, that means our gross output, that is x1, x2 and x3, we got our gross output should increase to 292 465. 292 should be produced by the agricultural sector. Okay, 460 by manufacturing sector, and 504 should be units should be produced by the service sector. When the final demand changes by 100, 200 and 300 for agricultural, manufacturing and service sector respectively. I hope I make myself clear in this video. It was a very long video. Thank you.